Section 12.10, solving probability problems by using combinations. So we're going to take all the skills that we've learned, combinations, permutations, probability, and we're going to put them together in problems, and you're going to have to use those skills to assess the probability. So this first example is a committee of 3 women. A club consists of 4 men and 5 women. 3 members are to be selected at random to form a committee. What is the probability that the committee will consist of 3 women? Okay, so remember when you do probability, this is going to be completed as a fraction. And so you first want the probability of the number of possible committees with women in the numerator. And you want to divide that by the total number of committees possible. So in this situation, order does not matter because the positions are not ranked, so you're going to use a combination. So in order to figure out the number of total women committees, you first have to find the total number of women. There's 5 women, and you're going to select 3 of the 5 women. So you would, for your numerator, do 5 combination 3, and that would tell you the number of female committees that are possible. Then in your denominator, you need to figure out the total number of committees possible. Well, total, there's 4 men and 5 women, so there's a total of 9 people, and you have to pick 3 out of the 9. So total number of committees is 9 combination 3. I personally would just use my calculator to find 5 combination 3 and 9 combination 3. 5 combination 3 is 10. 9 combination 3 is 84. And then remember, you always want to give your probability as a reduced fraction. So both of these items are even, so you know they're both divisible by 2. So that would give you 5 over 42. So the probability of selecting an all-female committee when 5 of 9 people are female would be 5 out of 42. Not likely, but it is possible. Let's look at another example. A temporary employment agency has 6 men and 5 women who wish to be assigned for the day. One employer has requested 4 employees for security guard positions, and the second employer has requested 3 employees for moving furniture in an office building. So the first question I would like to find the probability that 3 men will be selected for moving furniture. Okay. So question 1, it's the probability that 3 men will be selected to move furniture. Okay, so first thing you have to do is find all the possible ways to select 3 men, and that's going to be in your numerator. Then you have to find all the possible ways to select 3 people, and that is going to go in your denominator. So in this situation, your agency has 6 men. So all the possible ways to select 3 of them would be 6 combination 3. Your agency has 6 men and 5 women. That means your agency has 11 people. So the total number of ways to select 3 people would be 11 combination 3. And again, I would use my calculator. 6 combination 3 is 20, and 11 combination 3 is 165. And then I would reduce that fraction. That'll reduce to be 4 out of 33. A second question about this scenario, what is the probability that 3 men will be selected for moving furniture and 4 women will be selected for security guard positions? So question B, we want 3 male movers and 3 female security guards. Oh, sorry. 4 female security guards. Okay, so you're going to have multiple events in this situation. And whenever you have multiple events, you have to multiply the probabilities or the possibilities together. Okay, so first we have our 3 male movers. So again, there were 6 men. We're going to select 3. So that would be 6 combination 3 for our 3 male movers. Then we want 4 female security guards. There's 5 women. We want to select 4, so that would be 5 combination 4 for the number of ways we could choose security guards. And then we have to multiply these 2 events together because whenever there's multiple events happening in a row, you multiply their probabilities. Now we need to divide by the total number of possible ways to select these people. So we're selecting 7 people total, 3 to be movers and 3 to be security guards. We have 11 people on our list, so our denominator is going to be 11 combination 7. Again, I would use my calculator to do the combinations for me. 6 combination 3 is 20. 5 combination 4 is 5. And 11 combination 7 is 330. Remember that you should multiply your numerator first before reducing your fraction. So 10 out of 33. Let's do one more example just to make sure everybody is on the same page. Let's look at example 5. Example 5. Connor Shanahan's rare coin collection is made up of 8 silver dollars, 7 quarters, and 5 dimes. Connor plans to sell 8 of his 20 coins to finance part of his college education. If he selects the coins at random, what is the probability that 3 silver dollars, 2 quarters, and 3 dimes are selected? So remember, because we have multiple events occurring, we're going to have to multiply these probabilities. And in the denominator, we're going to have all the possible ways that we can sell 8 out of 20. So Connor has 20 coins total, and he's going to sell 8 of those. So 20 combination 8 will be all the different number of ways Connor could randomly select 8 coins from his pile. Now, they have a specific way they want it to happen. He has 8 silver dollars, and he wants to randomly select 3, so that would be 8 combination 3. He has 7 quarters, and he wants to randomly select 2, so that would be 7 combination 2. And he has 5 dimes, and he would like to randomly select 3, so that would be 5 combination 3. And remember, you have to multiply those 3 events together in the numerator. So 8 combination 3, if you do that in your calculator, is 56. 7 combination 2 is 21. And 5 combination 3 is 10. 20 combination 8 is 125,970. If we multiply across our numerator, we would have 11,760 ways to select these coins. And if we reduce our fraction, we'll get 392 out of 41.99.